Imagine a world with tall buildings and long bridges far connecting us, and rockets fly in sky. Have you ever thought how we measure the distance and the height of objects which are far away from us? So, its answer is trigonometry. Trigonometry is a branch of mathematics that studies the relationship between the sides and angles of a right triangle. It is not just a theoretical subject, but it has many practical applications in our daily life. This model demonstrates how trigonometry is applied to the real life scenario. Before we explore the applications of trigonometry, it is important to know the concept of Pythagoras theorem because Pythagoras theorem is a cornerstone of the trigonometry. The Pythagoras theorem states that the square of hypotenuse is equal to the sum and square of two other sides of right triangle. These two other sides are perpendicular and base. To understand it in a better way, consider an example. Here we have a right triangle that is A, B and C. Let's apply the Pythagoras theorem here. This is AC, which is hypotenuse, and this is 5 centimeter. So the square of 5 centimeter is 25. And AC and AB is a base, and the AB is perpendicular, which is 3, and BC is base, which is 4. So the sum and square of perpendicular and base is also 25. So we can say that Pythagoras theorem, we can say that the square of hypotenuse is equal to the sum and square of perpendicular and base. Now the question arises that why Pythagoras theorem is important in trigonometry, because all the trigonometric ratios are based on the Pythagoras theorem. Let's have a look on our first application of trigonometry. Imagine a tree snapped by the storm and we have to find the actual height of the tree. As you can see, this broken tree forms a right triangle A, B, C, and this broken part is hypotenuse that forms an angle of 30 degree with base, and this is perpendicular and the base is given 8 meter. So let's apply the here we have to find the original height of the tree. Let's find the perpendicular first. So here we can use the trigonometric ratio tan theta. Tan theta is perpendicular upon base. Here perpendicular is AB and base is 8, and tan 30 is 1 by root 3. So when we solve, we get AB as 8 by root 3. Now let's find the hypotenuse. So here AC is a hypotenuse and we know the base. So base upon hypotenuse, that is cos theta. Cos 30 degree is root 3 by 2, and BC, which is base, it is 8, and AC we have to find. So when we solve, we get AC as 16 by root 3. So we know the perpendicular as well as hypotenuse. When we sum, we get the height of the original height of the tree. So when you sum both of them, you get 13.84 meter. So the height of the tree is 13.84 meter. So trigonometry has ability to reconstruct the past. Let's have a look on our second application of trigonometry. The girl is standing over here and she is looking at the top of the building. We have to find the distance between the girl and the building. Here, when she looks at the top of the building, the angle of elevation form is 30 degree. So we have to find the base and we have perpendicular. So we can use the trigonometric ratio tan theta. Now the value of tan theta is tan 30. Tan 30 is 1 by root 3, and as you can see, this is ABP triangle. So AB is perpendicular, which is 10, and AP, which is base. So when we solve, we get AP, which means base, as 17.32 meter. So the distance between the girl and the building is 7.32 meter. Now we have to find the height of the flag. Let the height of the flag be x. So here AD, which is perpendicular, with x plus 10 meter, which is the height of the building, x plus 10, and AP, which is base, which we have find here 10 root 3. So, and angle of elevation when she look at the top of the flag is 45 degree, and The perpendicular upon base is tan theta, and tan 45 we know is 1. So when we solve, we get 7.32 meter. So the height of the flag is 7.32 meter. Let's have a look on our last application of trigonometry. Imagine a scenario: the girl is standing at the top of the tower and she's looking at the boat, and we have to find the angle of depression. Let us understand what is angle of depression. So angle of depression is the angle, this is a horizontal line, this line is parallel to the ground, and this is a line of sight. So angle of depression is the angle between the line of sight and horizontal line. The angle formed here is equal to this angle because both are alternative angle and the line of sight act as a transversal. So we have to find the angle of depression here. As you can see, the line of sight, which is hypotenuse, it is 6 meter and the base is 3. So perpendicular upon base, we know it is, we have hypotenuse and base. So base upon hypotenuse, which is cos theta, base is 6 and the hypotenuse base is 3 and the hypotenuse 6. So when we solve, we get 1 by 2 is equals to cos theta. So 1 by 2 is cos 60. So here the angle of depression formed is 60 degree. Now we have to find the height of the tower. We do not need to apply here trigonometric ratio because this is a right triangle and the two sides are given that are hypotenuse and perpendicular. So we can find the height of the tower by using Pythagoras theorem. So as you can see, this is a ABC triangle, AB, which is hypotenuse and it is given 6 meter, and AC, which is perpendicular, and we have to find AC, and BC, which is base, which is 3. So 6 square is 36, and we know we have to find AC, and the 3 and the square of 3 is 9. So when we solve, we get AC as root 27, and when we solve it further, we get 5.19 meter. Thank you so much.